we are going to start Unit 14. Unit 14 is all about factoring. So when we think of key skills you need to move forward in geometry and then Algebra 2 your junior year and so on, factoring is one of the key topics that we need to understand. So as we go through Unit 14, we're going to take it slowly and really focus on one key thing a day. But just as so you know, as we move forward, this is a key concept. The geometry teachers for next year have indicated to us this is very important. So when we start, we say, what does it mean to factor a number? So what does factor mean? So factor, what we can do is we can break down a number. So I would call it to break down a number. So what that would mean to me is, let's say I had the number 8. I am looking for ways that I can break down to get to the number 8. So I can take 1 times 8, that equals 8. I can take 2 times 4, and that equals 8 as well, right? So I can find factors of the number 8 by breaking down that number. So this, what I just drew here for you, is called a factor tree. And I like using this when we have to factor a number. It just keeps you pretty organized in doing so. So if we move down here, we're going to look at the examples. So we want to use a factor tree. So it says find the factors of the number 6. So I'm going to set up my factor tree, and I put my number on the top. And then I'm looking for numbers that can multiply to equal 6. So 1 times 6, right, that equals 6. 2 times 3, that equals 6. And if you keep going, I'm going to do this as an example here for you. You can do 3 times 2, right? That also equals 6. And 6 times 1 also equals 6. But what we don't show is we don't need to show the inverse. We don't need these, right? Because we already included those numbers above. So if I had to list the factors of 6, I have 1, 2, 3, and 6 are my factors. All right, let's go to the next example, which is 24. So I'm looking for factors of the number 24. So I start in this column here. I always start with the low number 1, and then I go up. So I have 1 and 24. And then I'm going to look at the number 2. 2 times 12 is 24. And then I look at the number 3. 3 times 8 is 24. The number 4. 4 times 6 is 24. The number 5. And here I can say, oh, I can't, 5 does not go into 24 as a whole number. So 5 is not a factor, right? All right, so once you get to this 4, see how I tried 5 and it didn't work. And then I have 6 in the left column or the right column. That means I have completed all my factors. So my factors for the number 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Okay, you do not have to rewrite in a row like that. You can leave your factors, for me, like a factor tree, just like this, and I can grade off of this. Okay, unless you would see that it asked of you differently. All right, next example, the number 52. All right, so we have 1 and 52, 2 and 26. And as you get some of these different numbers, you might need to use your calculator, which is fine. So let's try 3. 52 divided by 3 does not work. Let's try 4. 52 divided by 4. I get 4 and 13. We know 5 is not going to work. Let's try 6. Nope. Let's try 7. Nope. Let's try 8. I think we're done. No, we know it's not 9. We know it's not 10. So then we know it's not 11. And we know not 12. All right. So we are done with our factors. So the number 52, right, has these factors. Okay, so that is finding the factors from a number. So next concept is, what is the greatest common factor? So greatest common factor is when we have multiple terms, it is what factors they all have in common. And it would be the largest number that they have in common. And we often will see greatest common factor abbreviated as GCF. So if we wanted to find the GCF, the greatest common factor of the numbers 10 and 30, what I would do is I'm going to have two factor trees, one for 10 and one for 30. So first I'm going to do 10, and then I'm going to find the factors for 30. And now I'm looking at my factors, and I'm going to look for the largest number. So here I have 10, and I have 10. The largest number in common, I should say. So the GCF of 10 and 30 is the number 10. Look that up so you can see that. All right, next we have to look at the numbers 24 and 72. So we are finding the factors using factor trees. Then we have to do 72. Oops, not 4, 3 and 24. 4 and 18. 6 and 12. 8 and 9. Lots of factors for 72. So I'm going to look at both columns, and I'm looking for the largest number they have in common. So I see 24 in both columns. That's the largest number. So my GCF is 24. All right, next we're going to look at 12 and 40. So we are finding our factors first. 2 and 20, 4 and 10, 5 and 8. Okay, and then we are looking for the largest number they have in common. So the largest number these two have in common is 4. So my GCF, greatest common factor, is 4. Okay, the next example starts using variables. We can also find the GCF of variables. So I have here x squared and x to the fifth. So x squared is 2x's, right? And x to the fifth is 5x's. So it's asking me how many x's do these two terms have in common. So they both have 1 and they both have 2. So my GCF is x squared. I should do that in pink so it's all the same. All right, if I look at the next example, I have x squared and y squared, and then x and y to the third. So how many x's do I have in common? Right, they both have 1x. And how many y's? They both have 2 y's. So my GCF is going to be x, y to the second. Next example, we have 8x squared and 12x to the fifth. So for these, we actually have to do two things. We have to look at the number and then the variable. So first I'm going to look at the numbers. And then I like to do underneath, I'm going to write my variables. All right, so let's first look at our numbers. What is our greatest common factor? Is the number 4. And then how many x's do both have in common? They both have 2 x's. So my GCF becomes 4x to the second. All right, so that is your notes. Oh, we got one more page. Okay, so next we have to factor out the GCF. So first we have to look and we have to figure out what is the GCF. So I have 3x squared and 2x squared. Oops, sorry, 3x to the third. So in terms of my numbers, right, both of these are prime numbers. So my GCF is just the number 1. And then I have 3 x's and 2 x's. So 2 x's. So that means my GCF is going to be x squared. So what I'm going to do here is I can take out my x squared. And I'm going to then put parentheses, and I'm going to write what's left. Let's get a different color here. So what's left of my first term is a 3 and an x. And what's left in my second term is just a positive 2. So this is how we would factor. We would take out the GCF of these terms. All right, let's do another example. Hopefully, as we do a couple more examples, it'll make sense. So first we're looking at 3x squared, we have 3x, and we have negative 60. So number-wise, we have to find our 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Okay, so we're looking for, let's put our x's down below. So next we're looking for our GCF. So number-wise, 3 is the highest factor I have. So my GCF is going to be the number 3. So we're going to take that out. And then we're looking for what's left. So what's left, right? I have a 1 and x squared. So that's just x squared. My second term plus x. And my third term, what you're going to look for is what is the number next to the GCF you pulled out. So plus 20. Now, to check to see if I did this right, what you could do is you would distribute. So we would end up with 3x squared plus 3x plus 60. Oops, and I can tell I made a mistake here, which we're going to erase this, right? Because I need this to be minus 60. So I need to have minus 20 is my answer. All right, last example. So we have 9x squared and 36. So we're looking for our GCF. And I can see that my GCF is going to be the number 9, and I have no variables in common. So I'm going to take the GCF out, and then I'm looking for what I have left. So I have to do what is next to the GCF. So I have x squared plus 4. And to check, I can distribute 9x squared plus 36, right? And that is the same as my original. So I know that I factored it correctly. All right, that is your notes for day 1 on